Imagine staring at a black and white photo of a sunlit meadow. The grass is lifeless, the sky muted, and the clouds lack definition. What if you could breathe color into this scene, restoring its vibrancy? That's the magic of image colorization, a process where AI transforms grayscale images into lifelike color. But here's the challenge: there's no single correct answer. A sky could be blue, purple, or even pink, depending on the time of day. So how do machines figure out the right colors? Let's explore the cutting-edge AI techniques behind this fascinating process. At its core, image colorization is a complex puzzle. When you strip color from an image, you're left with just brightness, a single dimension of data. But color exists in 3 dimensions: red, green, and blue. The AI must infer these missing values, essentially solving a problem with millions of possible solutions. Early methods treated this as a math problem, trying to predict exact pixel values. But that's like asking a robot to choose one correct answer when the real world is full of ambiguity. This research takes a different approach. It leverages 2 powerful AI tools: Convolutional Neural Networks, CNNs, and Generative Adversarial Networks, GANs. Think of CNNs as expert pattern detectors, like a detective who knows grass is typically green and skies are blue. GANs, on the other hand, operate like a creative artist and critic working in tandem. The generator, the artist, adds color to a grayscale image, while the discriminator, the critic, evaluates whether the result looks realistic. This dynamic creates a feedback loop, pushing the AI to refine its output until it's nearly indistinguishable from real color. The study compared 2 approaches. The first, classification-based colorization, divides the color space into 313 possible color pairs, like 313 paint options. The AI selects the most probable color for each pixel, but instead of forcing a single choice, it calculates probabilities. This allows it to handle ambiguity, like deciding whether a sunset is orange or pink. The second method uses a GAN. The generator starts with a grayscale image and applies color, while the discriminator compares it to real-world color images. Over time, the generator learns to mimic realistic color patterns. It's akin to teaching a child to draw by showing them examples and correcting their work, except the child is a machine learning model trained on vast datasets. Testing on the CIFAR10 dataset, 32 x 32 pixel images, the GAN method outperformed the classification approach. It achieved 33% pixel accuracy, meaning 33% of pixels were nearly perfect, compared to just 0.9% for the classification method. The GAN also scored higher on metrics like PSNR, a measure of image quality, and SSIM, which evaluates similarity to the original. But the real test was human perception. Participants rated images on a scale of 1 to 5, with higher scores indicating realism. GANs averaged 3.7, while CNN scored 2.3. When shown grayscale, classification, and GAN results, people often chose the GAN version. It wasn't just about numbers, it was about feel. The GAN's colors felt natural, as though they belonged in the scene. So what does this mean? Image colorization isn't just about adding color, it's about teaching machines to understand context, texture, and even mood. While models still struggle with certain colors, like red, which they often misinterpret, the progress is undeniable. GANs deliver more realistic results, but require more computational power and training time. It's like choosing between a fast, basic paintbrush or a high-precision tool. Both work, but the latter offers smoother, more nuanced outcomes. Researchers aren't stopping here. They plan to test these models on larger datasets like ImageNet and explore techniques like variational autoencoders, VAEs, to further refine AI's color sense. The goal? To push the boundaries of what machines can do, making every photo feel alive with realism. Next time you see a restored vintage photo, remember, it might be the work of GANs or CNNs. Thanks for watching. Hit subscribe for more deep dives into the fascinating world of AI.